complement of an event is the probability of that event not happening. So the notation that we use for this is actually the same notation that we used for finding the mean. If you remember, x bar was the mean. We're going to use the same notation here, but it's in a different context. It means something else. So try not to get that confused with average. It just happens to be that we use the same notation to mean something else. So in the context of probability, a bar is not the average, but it is the complement of event A. So it means the probability of event A not happening. Okay, so let's look at the event of rolling a six-sided die and getting a 4. So we're going to take this six-sided die, roll it, see if we can get a 4. So the probability of that, well, there's one way to get a 4 out of the possible 6. So the probability of event A is 1 out of 6. Then to find the complement of that, so that's the probability of not rolling a 4, well, there's a couple ways we can think of this. Either we could say, well, there's 5 ways to not roll a 4, so that's going to be 5 out of 6, and that's a perfectly valid way to do it. However, sometimes it's not quite so easy to count up all of the ways of something not happening. So another way we can do this is just subtract that probability from 1. So remember that a probability of 1 means that something is going to happen. It's the highest probability that you can have. And so actually if we take 1 and subtract off the probability of event A, then we will get the probability of the complement. So another way we could have done this would have been to take 1 and then subtract the probability of event A happening. That will give you the complement. So to work this out, 1 we could rewrite as 6 divided by 6, because 6 divided by 6 is 1. And then 6 divided by 6 minus 1 divided by 6, that's 6 minus 1 is 5 out of 6. So that's another way to get the probability of the complement of an event. Now again, you might be thinking, well, it's easier just to say there's 5 ways not to get a 4, and so I'm just going to do it that way. But again, it's not always quite so easy to count up all of the different ways of something not happening. So sometimes if you're wanting the complement of an event, it's easier just to find the probability of the event and then just subtract it from 1. Okay, let's look at rolling 2 dice now. So if we're rolling 2 dice, then we've got a whole bunch of different options. So if you think about this, we could roll a 1 and a 1, or we could roll a 1 and a 2, or a 1 and a 3, or a 1 and a 4. If the blue one's 1, we've got 6 options for the green one. Well, then the blue one could be 2, and then we've again got 6 options for the green one. If the blue one's 3, we've got 6 options for the green one. We've got all these different options. Let's lay them out in an array, and that's what this is. So we've got one of the dice going up top. We've got options 1 through 6, and then along the bottom 1 through 6. And so we could have, and each of these describes the possible outcomes. So them both being 1, this one being 1 and this one being 2, this one being 1 and this one being 3, this one being 1 and this one being 4, and then lay them all out like that. So we can use this then to kind of count up probabilities. Okay, so probability of event A. Well, event A is the sum of the dice being 1. Well, there's actually no possible way to get a sum of 1 if you have 2 dice, because the smallest roll you can get on each die is 1, and so the sum of those is going to be 2. So the probability of getting a sum of 1, well, there's no way to do that. There's 0 ways to get a 1, and so that's 0 out of the possible, and there's 36 possibilities here, so 0 out of 36, which is just 0. Probability of B, well, event B is the sum of the dice being 2. Okay, well, there's one way that this can happen. If they're both a 1, that's going to be a probability of 1 out of 36. Probability of event C, that's the sum of the dice being 5. Well, let's look at all the ways that we can get a 5. So we can get a 5 from having 4 and 1, from 3 and 2, 2 and 3, and 1 and 4. So you'll notice that all the 5s are along a diagonal here. And actually all of them, all the numbers we can get are along a diagonal. But in any case, there's 4 ways to roll a 5. And so we get 4 out of the possible 36. Well, that's going to be 1 out of 9 if we reduce that. Probability of D, that's that the sum of the dice is 7. So let's look at all the ways we can get 7. Well, we've got a 6 and a 1, 5 and 2, 4 and 3, 3 and 4, 2 and 5, 1 and 6. So along this diagonal, this is all the ways to get a 7. Now you'll notice that there's more ways to get a 7 than there is to get a 5. And in fact, 7 has the most number of possibilities. So there's 1, 2, 3, 4, 5, 6 ways to get a 7. So that's 6 out of 36, which is 1 out of 6. So actually rolling a 7, if you have 2 dice, rolling a 7 is the most likely outcome. There's the most number of ways to get a 7 more than any other thing. And this is why, if you've probably heard, lucky 7s, this is why. So 7 is the most likely outcome for rolling 2 dice. Event E is getting a sum of 8, so that would be, you could have 6 and 2, you could have 5 and 3, 4 and 4, 3 and 5, 2 and 6. So there's 1, 2, 3, 4, 5 ways to get an 8. So that's a probability of 5 out of 36. Well, that one can't be reduced. Okay, now let's look at complements. So the probability of the complement of A, or A bar, so to get that, we could again just look at the grid here and figure that out, or we can subtract it from 1. So if we think about the number of ways to not get a sum of 1, well, there are 36 ways not to get a sum of 1, so that's going to be 36 out of 36, which is 1. Or again, we could just think of taking a probability of 1, subtracting off the probability of event A, which is 0, and we get 1. Either way works just fine. Okay, let's look at the complement of C. So again, C was the sum of dice being 5. Well, there was a 1 in 9 probability of getting a 5. So what we could do is we could take 1 and subtract off of it 1/9. Well, 1 could be written as 9/9 minus 1/9 then is going to be 8/9. Now again, we could have gotten this by counting up all the ways that there is not to get a 5, but that would be pretty tedious. So, we could say, well, here's one way to not to get a 5, here's another and another. So there's 1, 2, 3, 4, 5, 6, 7, 8. Count up all the ways of not getting a 5, but that would be pretty tedious. It's much easier just to take 1, subtract off the number of ways to get a 5. All right, complement of D, that's the number of ways not to get a 7. So again, we could count up all of these ways not to get a 7 and all of these ways not to get a 7. We could count up all of that and find that probability, but it's much easier again just to find the probability of getting a 7, which is just along this diagonal, and then subtract it from 1. So we'll do 1 minus the probability of getting a 7, which was 1/6. So 1 is 6 out of 6, subtract 1 out of 6, and you get a 5/6 probability of not rolling a 7.